Good morning, everybody. Am I audible?
Good morning, sir. Yes.
Okay, let's wait for 2 minutes and then we will start the so that rest of the student can join. Okay, so let us start the class because I think nobody will again join. And if they join, we will let them join in between. So, a very good morning to everybody. Mm, Today, we are going to continue our discussion with the discrete time Fourier transform that we have started last week. And in the last day, we have discussed about some properties of discrete time Fourier transform. And today we will just elaborate with that. We will just go with more of the properties. We will try to prove the properties, etc., using discrete time Fourier transform. And then we will do some numericals on discrete time Fourier transform. We will try to solve inverse discrete time Fourier transform. And that is our chapter, or that is our module of discrete time Fourier transform. And then we will go for the discrete Fourier transform, DFT. So DFT and DTFT are the two different procedures. And we will see why they are different and why they are called so. Okay. So first of all, let us recap something, and we recap that when we will do transform and when we will do Fourier series. That is the important thing. Fourier transform and Fourier series depends upon two things. One is the signal, whether the signal is periodic or non-periodic. If it is a non-periodic, we will do the transform. If it is a periodic, we will just take Fourier series about that signal. Understand?
Yes, sir.
Okay. So today we will start with our Let's share the screen. So we have already proved the linearity property, and we have shown the periodicity property, and we are yet to prove the periodicity property for Fourier discrete time Fourier transform. So let us start with that. Today is our 31st, last date of the first month of this year. So what I told about periodicity property, periodicity property, we said that let Fourier transform of x of n be x of e to the power j omega. Then x of e to the power j omega is periodic with period 2 pi if x of e to the power j omega, omega plus 2 pi m equals to x of e to the power j omega, where m is an integer. So this is the property. That is the periodicity property of discrete Fourier transform. So what is our question is that we have to prove this property. So how we will prove this property? It is very much important. So let us see that the sequence is x of e to the power j omega plus 2 pi. So if I do this formula and supplement the formula to something about the Fourier transform formula, that is summation of n equals to minus infinity to plus infinity xn e to the power minus j omega n, then we can tell that this is equals to x of e to the power j omega. So depending upon the definition of Fourier transform, we have to prove this, actually prove this thing. So let us try the proof. what we have x of e to the power j omega plus 2 pi m. This we have. So let us think that this is our signal. So if this is signal, if I, from the definition of Fourier transform, if we expand this, what will be the expandation? Expandation will be summation of n equals to minus infinity 2 plus infinity x of n into e to the power minus j into omega plus 2 pi m into n, because e to the power minus j omega n. So omega is nothing but now omega plus 2 pi m. Omega has been transformed to omega plus 2 pi m for this case. Okay, for this case. So if I differentiate it, because this is a plus, so e to the power j omega n, I take it, and because it is how much, e to the power minus j, if I take the n inside, so omega n plus 2 pi mn. So let us write it like this: summation of n equals to minus infinity 2 plus infinity x of n into e to the power minus j omega n. We can write this into e to the power minus j omega, sorry, omega y, omega, no, omega, e to the power minus j 2 pi mn. We can write this. So now for the e to the power minus j theta formula, if m and n are integers, e to the power minus j theta equals to 1. That is our trigonometrical formula, or the formula that we know. If m and n are integers, then we can write what? Then we can write e to the power j 2 pi of mn equals to 1. That is e to the power minus j 2 pi theta equals to 1. So I can write summation of n equals to minus infinity 2 plus infinity x of n e to the power minus j omega, and this is equals to 1. So in this I can put 1. So that is equals to what? X of e to the power j omega. So this is the proof you have told. We have to prove this is equals to x of e to the power j omega. So that is proved. So this is the periodicity property for DTFT, or discrete time Fourier transform. We are now going to the next properties of Fourier transform. Every property there you must try to, what I will tell, try to do the proof of every property, because the proof of this property is nothing but the proof of, actually it is the practicing of our Fourier transform. So Fourier transform problem, the doing of problem of Fourier transform, or solving the problem of Fourier transform, if you solve the properties proof, then actually you are doing the Fourier transform. So it will help in doing Fourier transform numericals. So that's why every time a property is given, try to prove it. Sometimes it comes to examination, that is okay, but that will help you to practice more discrete time Fourier transform. Okay, without much delay, let us go to the next properties because we have a limited time and your examination is coming on. So we have to complete it. So DTFT, next property is time shifting property. It is 31st, 1, 22. The property is called time shifting. So what is time shifting property? Let Fourier transform of x of n equals to x of e to the power j omega. So f of x of n minus m equals to e to the power minus j omega n into x of e to the power j omega. Also, we can write Fourier transform of x of n plus m equals to e to the power j omega m. So this is also m into x of e to the power j omega. Okay. So if I want to prove this, how we will prove? Let us see. By definition of Fourier transform, ft, we can write x of e to the power j omega equals to Fourier transform of x of n, that is equals to summation of n equals to minus infinity to plus infinity x of n into e to the power minus j omega n. So that is the Fourier transform. Now, actually, Fourier transform of x of n minus m equals to nothing but a summation of n equals to minus infinity to plus infinity x of n minus m into e to the power minus j omega n. That is equals to, if I change the limit, if I let n minus m equals to p, okay? That implies n equals to p plus m, no problem. So when n tends to infinity, if I change the limit, then what will be? P tends to minus infinity. Now when n tends to plus infinity, P tends to what? Plus infinity. There will be no change in the P, in the limit. So that is the summation of P equals to minus infinity to plus infinity x of P into e to the power minus j omega m into e to the power minus j omega p. Sorry, I jump one step. It will be not applicable for you. M plus p. So that can be written as a summation of p is equal to minus infinity to plus infinity x of p e to the power minus j omega m into e to the power minus j omega p. So it can be written as e to the power minus j omega m into summation of p equals to minus infinity to plus infinity. Now tell me why I take this out. Because everything is in p, but this is in m. So I can take it, treat it as a constant and take it out of the summation. So x of p into e to the power minus j omega p. So that can be written as e to the power minus of j omega m into summation of, in the p I write n. So n equals to minus infinity to plus infinity because there is no change in limit. X of n into e to the power minus j omega m. Where, why? Because let us take p is n. So that is nothing but equals to e to the power minus j omega m into x of e to the power j. Now your task is to prove this one. Your task is to prove this one. You have to prove this. I have done this. You have to prove this. I will add this to your assignment. No problem. Next. Today is 31st. So what is the time reversal property? It says that let function of Fourier transform of xn be x of e to the power j omega, then Fourier transform of x of minus n will be x of e to the power minus j omega. So if I do the proof of this, we know f of x of n equals to summation of
n equals to minus infinity to plus infinity. X of n into e to the power minus j omega n. So f of x of n x of minus n summation of n equals to minus infinity to plus infinity x of minus n into e to the power minus j omega n equals to summation of let p equals to minus of n. So when n equals to infinity minus p equals to plus infinity, n equals to plus infinity, p equals to minus infinity. So summation of p equals to minus infinity into plus infinity x of p into e to the power j omega p. So what is the problem? We have to take here minus. So what I write, summation of p equals to minus infinity plus infinity x of p into e to the power minus j omega into minus p. Okay, so that will be to the power minus p. Okay. So now what will happen? So that can be also written as x of e to the power minus j omega, as because this equation is similar to this equation. So we can customize that this is like this, so we can write x e to the power e j omega. Okay. This is good. Next, the most important, there are more. There, if you see any books, there you will see there are more types of properties of Fourier transform, discrete time Fourier transform. But what are the importance and what are required for our numericals that I am doing? I am just highlighting on the important properties and their proofs. So next important property for our need, that is our convolution property, which is very much important one. So one of the most important was convolution property. So let us do some convolution property. So convolution property. What is this convolution property? You said that if Fourier transform of x1n be x1 e to the power j omega and Fourier transform of x2n equals to x2 e to the power j omega, then Fourier transform of x1n convolution with x2n is equals to Fourier transform of each signal multiplied signal. It is x of 1 e to the power j omega and x2 of e to the power j omega. That means which is convolution in frequency domain, time domain is multiplication in the frequency domain. This is convolution. So how to solve it? Oof. So x of 1 e to the power j omega equals to Fourier transform of x1n. That is equals to summation of n equals to minus infinity to plus infinity. x1 n into e to the power minus j omega n. Now x2 e to the power j omega equals to frequency of sorry, just a moment. There is a network problem. x2n equals to summation of n equals to minus infinity to plus infinity x2n e to the power minus j omega n. So a Fourier transform of x1n convolution with x2n equals to summation of n equals to minus infinity to plus infinity in third bracket x1n convolution with x2n into e to the power minus j omega n. That is equals to summation of n equals to minus infinity to plus infinity into summation of I'm I am omitting this convolution m equals to minus infinity to plus infinity x1 m into x2 n minus n. So I have got the attendance of Alok Prakash, Shahzada Sawad, Talib Ansari, Ravi Kumar, and Abhijit Kumar. Now I got the Saroj Kumar, Kundan Kumar. Please, Kundan, please write your name like Kundan Kumar. Like Abhijit, please write your name, Abhijit Kumar. That will be, when I will see the chat, it will be helpful, okay? So this is the summation, that is convolution into e to the power minus j omega n. So if I omit the summation, then what will be I will get it. I'm going to the next page. Just a minute. Yes, what we are telling, I am omitting the summation. So that is giving her the time is limited, so it can be cutted. The link can be absoluted, but we will continue the next thing in the next, up to how much it will do, it will be continued in the next. N equals to minus infinity to plus infinity. Another summation will be for m equals to minus infinity to plus infinity. x1 m into x2 n minus m e to the power minus j omega n e to the power minus j omega m and e to the power j omega m and e to the power j omega m. So multiply e to the power minus j omega m and e to the power plus j omega m will get 1 because e to the power minus j theta into e to the power j theta equals to 1. So that's will be 1. So we can write summation of m equals to